Hey guys, well in this video I thought I'd do a comparison between the Clearpath servo motors and the servo motors from DMM Technology. Now when I posted the very first video on the DMM Technology servo motors and drives, I mentioned a few reasons why I chose to go with them over the Clearpath. I've been getting a lot of questions since I posted those videos, and so I thought I would try to clear some up with some side-by-side comparison, at least on paper. Now first, let's take a look at some Nema 23 frame size motors. The Clearpath servo motors are 75 volts DC. The DYN2 drives are also DC drives, so it should be a pretty fair comparison. One thing you may notice when you're searching through all the different servo motors that Clearpath offers is they have a lot of different options, and so it can get kind of confusing. I know personally I found it was confusing, and it wasn't until when I talked to an engineer that I got a little bit more clarification on the different options. The Clearpath servos have 3 different motor designations. A P designation, which is an intermediate motor. It gives you decent torque and decent speed. The S designation, which gives you more torque and less speed. And the D designation, which gives you higher speed but less torque. After looking at some of the options that I was going to use for my particular project, I came away feeling like I could use a little bit more speed. I was content, but I wasn't happy. If you look at some of the servo motors that are offered from Clearpath, they have the 2311S. Now the S is a high torque motor, so you're going to sacrifice a little bit of speed to get the torque. If you'll look at some of the specifications for this particular motor, we have the rated torque at 58 ounce-inch, the peak torque at 290. We have the rated speed at 2880 RPMs and the peak at 4000. Now by comparison, the DMM Technology motor paired with the DYN2, they have a 200 watt motor, which gives you a rated torque of 90 ounce-inch and a peak torque of 270. So the peak torque is a little bit less than the 2311S. However, the rated torque is about 80% more. Now the 2311S is rated to be about a 120 watt motor. So I'm not sure it's really fair to compare it to a 200 watt motor from DMM Technology, but I wanted to just put it on here just so you can kind of see what I saw. Now the 200 watt motor from DMM Technology, we can go 5,000 RPMs versus 4,000 RPMs, so a little bit more speed. The rated speed is about the same. Now when you pull up the charts for these particular motors, you'll notice, like I did, that the peak torque for the DMM 200 watt motor is 270 ounce-inch all the way up until 3000 RPMs, which is a really big deal. And the rated torque is 90 ounce-inch, again all the way up to 3000 RPM. But if you take a look at the Clearpath 2311S, your peak torque of 290 drops off at about 600, probably around 650 RPMs, and then it steadily declines all the way out until the max speed of 2880. And your 58 ounce-inch is only good up to 2880. Now the 2331P, which is a 193 watt motor, which is closer to the 200 watt motor. The P designation gives you a little bit less torque, but a little bit more speed. You can see that our rated speed is upped to 4,000, but our peak speed is still 4,000. And our peak torque is 310 versus the 270, but our rated torque is only 62 ounce-inch. But I thought this would be a good motor to kind of compare. So you can look at the chart here for the 2331 motor, and you can see that we have our 310 ounce-inch of torque out to about 800 RPMs, and then it gradually drops off to 4,000. And the 62 is stable all the way to 4,000 RPMs. And again, by comparison, you have 270 peak all the way to 3,000, and then 90 all the way to 3,000, and then the last 2,000 RPMs it drops off to around 50. So you have to kind of take those things into consideration when you're looking at the torque, because it's not always the peak, it's more the rated torque and the range of RPMs that this torque is going to be available. And for me, it seems like up to 3,000 RPMs, having 90 ounce-inch of torque is a lot better than what Clearpath offers. So you can see that as far as price is concerned, the DYN2 with the 200 watt motor is $275, and either one of these are going to set you back at least $100 more than what DMM offers. And as far as your commandable resolution for the DMM Technology servos and drives, it can be whatever you choose up to 65/536. Now, that's not realistic, because you probably won't get any kind of speed out of your motor if you've got your resolution or your commandable resolution set so high. However, by having the higher resolution encoder, this increases your response speed and also lowers your vibration. Your actual travel accuracy is not going to be affected too much, because it's dependent upon your backlash, your ball screws, but having the higher encoder resolution will let the servo motor settle into position a lot faster, and it'll lower the vibration when it's making its movements. The settling time is around 10 milliseconds for the DMM Technology servos and drives. Now, if we look at the DYN2 drive and the 400 watt motor and compare it, you can see that it's much higher as far as the peak torque versus the rated torque. Here we have 620 for the 2331S and 124 versus 179 and 541. But you can look how much speed loss you lose once you start getting into the higher torque motors from Clearpath. We're maintaining a 3,000 and 5,000 RPM on the 400 watt motor, which is around twice as much as the Clearpath. So I wanted to kind of cover just the Nema 23 and the DYN2 DC drives that DMM Technology offers, but I want to look at the DYM4 drives, which is what I chose to go with. Now, the DYN2 motor and drive will power the 750 watt motor, which is the motor I chose. However, there's just not enough power to really drive the motor to the full speed, so you're limited to 1500 RPMs if you go with the 750 watt motor and the DYN2 drive. But you can see that the motor is the same as far as the rated torque, the peak torque. It's just the rated RPM and the peak RPM changes when you switch over to the DYN4 drive. Now, I am going with the DYN4 drive for several reasons. One being that it's 220 volt AC, and that just completely eliminates the need for a big old DC power supply. Also, the ease of wiring and a much better speed and torque. Now you can wire the DYM4 drive to 110 volts, but you will limit the max RPM to around 3000 RPMs. But as you saw in my last bench test video, I was able to achieve a little bit higher RPM than that, but they rate it only to 3000 RPMs if you power it with 110 volts. So let's take a look at some of the options that Clearpath offers that I was going to use before I decided to go with the DMM technology, and that is the 3421S for my X and Y and the 3432S for my Z axis. Now the rated torque for the 3421 is 289 and the peak torque was 1094. The rated speed was 1090 RPMs, which would still give me rapids around 200 inches per minute, and the peak speed was 1400 RPMs. The DYM4 paired with the 750 watt motor gives me 339 for my rated torque and my peak torque of around 1000. So this is a pretty good comparison for these two motors. However, my rated speed is bumped up to 3000 RPMs and my peak speed to 5000 RPMs, which can give me much higher rapids, upwards to 500 inches per minute, based upon the 3000 RPM rated speed. So let's look at the charts on the 750 watt motor versus the 3421S. So the Clearpath 3421S, which is what I was going to use on my X and Y, gives me a peak torque of 1094 up to about 235 RPMs, and then it gradually drops down to the peak speed of 1000 RPMs. And this is where you can really see the difference when you're comparing the two. If we look at the DYM4 drive and the 750 watt motor, we have 1000 peak torque all the way out to around 3600 RPM. That's a big difference. That's almost that's over twice as much as the max speed of the Clearpath. That was really a big factor, deciding factor for myself. The rated torque is 289 for the Clearpath, and this is good all the way out to about 1100 RPMs, and then it kind of tails off till it gets to the max speed. The 750 watt motor from DMM Technology gives me a rated torque of 339 all the way out till 3000 RPMs, and then it gradually tails off to around 250 at 5000 RPMs. So you can see there's a really big difference as far as the higher RPM versus how much torque is available for these particular servo motors. You can kind of see the common theme between all the servo motors from Clearpath. The more torque you get out of the motor, the more limited you are to the RPM output, whereas you don't have that situation with the DMM Technology motors. Most all of their motors are 3000 and 5000 RPM. The one exception is the DYM2 paired with the 750 watt motor. Due to the higher torque of this motor, it limits the RPMs to around 1500. But still, even if you compare that with the 3421S, it's a much better side-by-side comparison between these two motors. And if you look at the price, it's a lot cheaper. You're going to save over $100 going with the DYM2 paired with the 750 watt motor. Now for my Z-axis, I decided to go with the 3432S. That's the one I was considering. So let's look at the comparison chart for it. So here we have the 3432S, and you can see that it's 1396 peak ounce inches of torque, but it's only good to about 250 RPMs, and then it tails off. That's a pretty big deal if you ask me. I mean, it's a lot of torque. It's only good up to about 250 RPMs, that's about 49 inches per minute. So once you get past about 49 inches per minute on your feed rate, your torque's going to start dropping off. It will maintain 392 ounce-inches of torque up to about 925 RPMs or so. If we compare it to the 750 watt motor that DMM Technology offers, you can see where our peak torque is 1,000 ounce-inches all the way up to 3,600 RPMs or so. It was really a pretty easy decision after I really compared the numbers. So that brings me to some of the key considerations of the Clearpath system. And so I broke these down into advantages, disadvantages. These are purely subjective. This is from my point of view, but this is how I saw it. Some of the advantages are a smaller overall size and package with the integrated unit. You do not need to mount a drive in the control box. And one thing that's I really couldn't tell if this is an advantage or a disadvantage. It may be an advantage to some. It was kind of a disadvantage to me. I found it kind of confusing. Is Clearpath offers a lot of different choices when it comes to size, speed, and torque. And then of course you have the optional enhanced encoder, so that could either be an advantage to you or a disadvantage. Some other disadvantages are the small size of the integrated drive has a lower power density. It requires running highly sensitive step and direction signals at long lengths. The Clearpath servo motors use encoders with a native resolution of 12,800 pulses per revolution. However, the positioning resolution is limited to 800 pulses per revolution or 6,400 for the advanced version. And of course you're going to need additional space for the DC power supply and the extra wiring. Things I mentioned in my earlier video. It's more difficult to troubleshoot and diagnose whether the problem is caused by the drive, the motor, or the encoder when you have it all integrated. And coming from a maintenance background, it's a lot better to have them separate. All the motor, drive, encoder, all the components must be replaced if there's a problem with any one of them. The longer lifespan components still need to be replaced even if the shorter lifespan component fails. With the integrated components, heat can be an issue. An external fan may be needed, which requires more wiring. And so that pretty much sums up some of the key considerations of the Clearpath system. And these are just some of the things that I looked at. So some of the key considerations of the DYN4 system. The DYN4 system uses encoders with a native resolution of 65,536 pulses per revolution on all their servo motors, and it's no additional cost. Now, up to a certain point, the extra encoder resolution really doesn't matter, but it does give you the ability to customize your resolution based on your servo speed in relationship to your controller pulse rate. The finer resolution limits vibration, increases response speed, and since the motor has a much finer reference on motor position, they're able to achieve higher acceleration and higher speeds. The DMM servo system runs the encoder cable from the motor to the drive at long lengths, but the signal is RS-485 serial protocol, which has a very high noise immunity. However, the highly sensitive step and direction signals only travel a short length from your drive to your breakout board. And again, as I mentioned earlier, it's easier to troubleshoot, diagnose whether the problem is caused by the drive, the motor, or the encoder. All the drive, motor, and encoder components can be replaced separately if there's a problem with any one of the components, which is going to save you time and money. Having separate components negates the need for an external fan. The servo run cooler. There's no additional space needed for a DC power supply. The DMM servos, they offer great torque and high speed, making choosing the right size servo motor very easy because they don't have so many different choices to choose from. I found it very easy to decide. I wasn't confused at all. The one disadvantage is having to have the drives mounted in your control box. So you're going to need a bigger control box to fit the bigger drives. After laying out the drives in my control box, I really didn't find that to be such a big issue. Alright, so that wraps up this video. As you can see, there were a lot of things that went into consideration before choosing the DMM Technology servo motors and drives. I couldn't have found a better fit for my particular build. So stay tuned. Hopefully after the first of the year, I can start putting together the control cabinet and getting the servo motors mounted and moving. I still need to finish up my honeydew project. Hopefully have about another week on that and it should be wrapped up. I'll post a link in the video description where you can find the DMM Technology website along with 3D models and all the charts and information I went over in this video. If you have any questions or suggestions, please feel free to comment. Thanks for watching the video. Please subscribe to the YouTube channel. Thumbs up if you like the video. And most importantly, be safe.